Hello, my name is Artem Golubev, and I'm CEO and co-founder of TestRigger AI. And I would love to talk today about new trends in QA automation. So why talk about new trends? We still have a problem that 70% of regression testing in 2019 is still manual. So there's a lot of struggle going on with testing. It's pretty hard. And what the result? 60 billion in losses just only in US due to bugs, and obviously damaged brand and reputation. Alright, so now let's talk about what trends are. Shift left, it's definitely a trend. Shift left, where basically developers will start to write code. Write code is written as and executed as early as possible, and tests are performed on every commit. And another trend I'm going to talk about today is autonomous testing. In different ways people test software autonomously. Well, how do we do testing today? There are several ways. There is a so-called automation, where people write code in Selenium, Cucumber, whatever, to produce tests. There is a record and play, and obviously there is a manual way. The record and play is where you'll basically go through website, will record your steps, and this would produce some kind of a test. So what are the problems with automation? Like, how is it possible that still 70% is not automated? Well, the problem is it's quite a challenge to create this kind of tests. It usually takes a couple of weeks to start and create first Android test, for example. And it's quite tough to support. If it takes half a day to create a test, then it takes on average 3 days over a test lifetime to support this test. And there is always stability issues. By far the largest would be because how it's written, meaning that like XPath, for example, if keeps changing, it means that test keeps failing, as well as there are expected infrastructure issues such as timeouts, like random issues, random crashes, and stuff like that. Well, how about record and play then? Well, it has also the same stuff. So first of all, it still takes time to create those tests. Like somebody with the knowledge of the project have to go through and create them. And we known to have stability issues since we would rely on XPath usually. And but the largest problem with record and play is support because of stability. Let's say your application have changed and now 90% of your tests failed from which were recorded. What would you do? You would have to re-record them from scratch in a lot of cases, which is a nightmare, and that's why a lot of companies no longer use this model. How about manual testing? Well, it's super stable. You can't get more stable than that. It's just exceptionally slow. It's on average takes a couple of weeks to do full end-to-end regression testing for most of mature projects. And like, you have to document those. It's almost the same as if you would write code. You're just coding it using English language by describing what needs to be done. So, like, what do we actually need to test. So let's take a step back and figure out, hey, like, let's say we are part of a testing organization. What are our KPIs? What are we measured against? How our performance is measured? And how do we produce value to the organization? And basically you test software and you catch bugs, but not all bugs are created equal. Bugs are important if they touch one of two areas usually, which are most important functionality or most frequently used. Okay, great. So then we can automatically generate tests, right? Well, we tried that kind of stuff before. We know that test generation is challenging, and the largest challenge of test generation is test stability. It's a similar thing as record and play, same issues. You'll have to deal with it with the stability issues. Now, how about if it would be possible to address those stability issues? Well, then test generation might work, and we can talk about that. Great. So, how do you address stability issues? First of all, obviously, abandon XPath, right? And in general, rethink testing. So how would you make it more stable? You can think of, okay, so how do people test software versus how would we write code to test software? And if you're thinking about, okay, how would humans test software, it's a little bit different. So we figure out controls by label associated with inputs, or we figure out what to do by what is written on a button, or how does the button look. And with the help of modern AI, it's just different approach to identifying controls on the page. You can actually solve it. Plus, you can address infrastructure issues by reasonable retries, if that's possible. Great. So we fixed stability issues. Now, what do we do? How do we actually test it? Well, there are a couple of ways you can generate tests. Number one is, let's say you want to address the most important functionality. How do you do that? Well, in a lot of cases, what humans do are using basically exactly same patterns over and over and over again. So if you look into how checkout on Amazon, eBay, and Walmart works, it's about the same thing. Yes, there are variations, but there are only finite ways to have variations in there. An example would be a login, right? So how to do login is just three largest approaches. Number one is that you just enter username, password, and click login, or you enter login first, click continue, enter password, click login, or you can click login button first and then perform the examples which I just mentioned. This is the most frequent ways people log in into applications. And this kind of patterns are basically repeated over and over. So if you have most of the patterns for industries coded, then you can basically, based on how application looks and what does it have in the UI, can figure out what most probably would be most important flows for this application, if you know the industry of this application. Great. So this is one way to do it. There is another way to, okay, great, but how about most frequently used functionality? Well, for that, we can iterate on record and play, and you could have a library which you can install in production, which would record, similar to Google Analytics, how users are using your application in production, and use that information to detect most frequently used patterns and build tests based on those. There you go. There's a couple ways to do it. Hold on, but what about API testing then? Because microservices now, right? Everybody does microservices. Well, great. If you do need autonomous testing for testing API, well, like there are ways to do it, and that is just using combinatorics. You literally can get an example of API call. We have parameters specified in the JSON for API call, calls the API, get a response. And then for the next call, you can figure out what parameters should be next time. Again, there are a finite number of patterns, and like, let's say dates. If the date's in the future, then you can keep it in the future, the same time in the future. Same, like if it is in the past, you can keep the same time in the past, and so on and so forth. This is one. And second, you go and try empty parameter for each parameter presented in the API call and see how does it work. There you go. So you just tested an API and might generate lots of tests. Great. Now, obviously, those approaches probably not going to cover everything, right? So think about it. Yes, there are certain patterns which you can figure out how application works, and you can record users in production. But how about connected systems? And a good example of that is the use of back office. Any e-commerce website would have a way to introduce new products through back office, and then this product must be purchasable on the main website, which have completely different URL, completely different type of users doing all this stuff. So how do you do that? Well, this is exactly what developers should actually do, right? Developers and tests should test these sophisticated scenarios which span across systems, which autonomous testing just can't do for you. That's it. So, like, there you go. Autonomous testing is not a threat in any means. To QA automation is just taking over simple parts and allow people and humans to focus on far more interesting and more sophisticated use cases. And it doesn't actually fall into any of existing categories. There are frameworks, more advanced frameworks. There is crowd testing and record play tools. This is all different approaches compared to autonomous AI-driven testing. Autonomous AI-driven testing is a tool which you can use to cover these simple areas so that you can now focus on something much more sophisticated. Great, let's do a demo. And I'll demo on this very simple website. All it can do is you can just enter data into the input and press update message, and it updates the message. And all you do is you just kick it off. This is example of a discovery. It is similar to whatever people call monkey tests, which would go everywhere. That's more sophisticated as a more sophisticated monkey test, go everywhere and figure out how stuff works and apply patterns to get to places. However, it's dramatically different in a sense that it actually produces a regression test. So next time you do it, it would actually apply what it learned about your system to test it for next time. In this case, it figured out, okay, so there's just one input, one button. Let's enter some data into this input and press the button. Great. And then also we're smart enough to figure out that after it did it, although message changed, it returned to the original screen, so there's nowhere to go anymore. So that's why it stopped and didn't go all the way further. Let's assume that we have now deployed a new version on our test environment, which we are about to release to production. How is it different? It has a new button. It doesn't do anything yet. And if you enter anything into the input and press update message, it does not update this message on the top anymore. So it's a classical functional regression issue. No more classical than that. Great, let's see how our system can cope with this kind of stuff. And bam, there you go. Obviously, you don't have to tell it what to do, and it detected that, yeah, there you go. Like if this message used to change, it doesn't do anymore. It doesn't change. However, it also saw, oh, and by the way, there is this new button. How about we create a test for new button and expand the baseline to include the test for this new button, because, well, we have a new button now. Great. And it can extract unique issues, because if you're dealing with thousands of tests, this is what you would need to do, is unique issues across all tests. And you can say, you know what, it's a feature, not a bug. How about we update the baseline, and next time we have application with expected to behave the same way? Or we say, you know what, yeah, there is an issue, but it's a known issue. Please don't break my CI. And there we go. This is an example. Bam, we set the feature, and now everything's green. Great, this concludes this shortened version of the presentation. And if you have any questions, want to connect, hang out, say hello, don't hesitate to email me at art@testtrigger.ai. Thank you for listening.